Hello, this is question 8 on your November 2020 paper 1 from AQA, so the AS paper. You have to find the equation of the tangent to the curve y equals e to the power of 4x at a particular point. So remember the tangent, for the tangent we need one point, which is this one, and the gradient is given by dy by dx, the derivative. So dy by dx of this function, the 4 goes to the front, and the e to the power of 4x doesn't change. This is the gradient in general at any point, and when x is a, because we need the equation of the tangent at this point, so x is a, the gradient is going to be 4e to the power of 4a, just substituting, which means if I use y minus the y of the point, gradient x minus the x of the point, and I substitute, I have y minus e to the power of 4a is going to be just substituting the point, yeah? The y is e to the power of 4a is going to be the gradient, which is 4 e to the power of 4a x minus the x of the point, which is a. And this is the equation of the line. They don't ask you to write in any particular way, so sometimes they say write with y the subject, but they don't. So I will leave it like this. You are going to get the marks. Find the value of a for which this tangent passed through the origin. So we have this straight line and we want to find a, so the line passed through the origin. So if it passed through the origin, that means that when x is 0, y is going to be 0. So we are just going to substitute in the line and we have to find a. So for e, for a minus a. So we have that e to the power of 4a is going to be 4e to the, I'm going to write the a at the front, so minus 4a e to the power of 4a. I can cancel e to the power of 4a, and then I have, sorry, this is plus, because I have a minus here and a minus here, yeah? And that means 1 is 4a, therefore a is 1/4, yeah? So the only thing I've done is substitute the 0, 0 in my equation of the line, yeah? And I just found a from there. So a is 1/4. And now it's a hence, so we are going to use that information, find the set of values of m for which this equation has no real solutions. You have to think of it first. So if you think about the graphs and what they mean, you're trying to find the intersection between this exponential graph that is doing something like this. So this is e to the power of 4x, and a straight line that passed through the origin. So it's a line like here, more or less. The gradient of this line, so this is m equals to mx. The gradient of this line, when the gradient changes, because we need to find m for no real solutions, when the gradient changes, if it increases, it will cut this graph. If it decreases, it won't cut. So we have to find what the limit is and when it's tangent. But when it's tangent, it's precisely that line that we found before, because this is my function, e to the power of 4x, and we were finding the tangent that passed through the origin. So the tangent that passed through the origin is this line when a is 1/4, sorry, yeah? So using both things, this is the tangent in general. When I substitute a by 1/4, I have the tangent that passed through the origin. So I have a line that is tangent here. Anything with a gradient smaller is not going to cut the line up to here. When it becomes negative, so if I have a line with negative gradient, it will cut the line. When I mean the line, I mean this one, exponential, yeah? So those are my limits. So let me rewrite the equation of the tangent. So the tangent in the origin is just substituting the a by 1/4. So is a is 1/4. So 4 times 1/4 is 1. So this is e. So y minus e equal, again, this is 4 times 1/4 is 1. So I have 4e for e brackets x minus a, and a is 1/4. So my line, the one that is tangent, is this one. And the gradient of this line is 4e. Yeah, the gradient of that line, we didn't need to write the whole equation, we can just substitute in the gradient. We know this is the gradient, so just substitute a by 1/4. I think this is clearer. So this is the gradient of the, so the gradient of the tangent is going to be 4e. 4e. So this one, if you want, so the tangent, I'm not sure if I'm going to be able to make it tangent. No, it's probably not. It's difficult, sorry. So this is the tangent. Let's say this is the tangent. This is this is this line. So let's say L1. Yeah. Any gradient below this one and up to 0 is not going to cut the line. Yeah. So that's my m. M should be smaller than 4e. I cannot include the equal, because if I include the equal, it will cut in 1 point, just in one, but it will cut in 1 point. And must be greater or equal than 0, because up to the horizontal axis, which is an asymptote, I won't have intersection, but anything slightly negative will cut. Very far away maybe, but it will cut. Yeah. So those are my limits for m. So this has no real solution. So this line and this line don't meet. Yeah, and that's the idea.